Marina wiring design presents unique challenges due to the presence of water and the potential for corrosion. Understanding the relevant electrical codes, such as the National Electrical Code or NEC, is crucial. Firstly, consider the shore power requirements. These vary depending on the size and type of boats the marina will accommodate. Common shore power voltages include 120 volts, 208 volts, and 240 volts, with amperage ranging from 30 amps to 100 amps or more. The NEC Article 555 specifically addresses boatyards, docking facilities, and marinas. Pay close attention to grounding and bonding requirements to minimize the risk of electric shock drowning, or ESD. All metal parts of the electrical system, including equipment grounding conductors, must be bonded together and connected to a common grounding electrode system. Secondly, select wiring methods suitable for wet locations. Use wiring with a moisture-resistant insulation, such as type THWN or THHN. Install wiring in conduit, such as PVC or rigid metal conduit, to provide physical protection and prevent water from entering the electrical system. All electrical boxes and fittings must be watertight and corrosion-resistant. Thirdly, ensure proper overcurrent protection. Each circuit must be protected by a circuit breaker or fuse of the appropriate size. Ground fault circuit interrupter, or GFCI protection, is required for all receptacles located near the water. This will help protect people from electric shock. Fourthly, design the power distribution system to meet the anticipated load demand. Consider the number of boats that will be using shore power simultaneously, as well as any other electrical equipment in the marina, such as lighting, pumps, and security systems. Use appropriately sized conductors and transformers to ensure adequate voltage is available at all points in the system. Fifthly, implement surge protection. Surges in voltage can damage sensitive electronic equipment on boats and in the marina's electrical system. Install surge protective devices or SPD at the main service entrance and at individual branch circuits to protect against voltage surges. Sixthly, plan for regular maintenance and inspection. Marina electrical systems should be inspected regularly by a qualified electrician to identify and correct any potential problems. Maintenance should include cleaning and tightening connections, inspecting wiring for damage, and testing GFCI receptacles. Seventhly, consider lighting design. Adequate lighting is important for safety and security. Use corrosion-resistant light fixtures designed for wet locations. Consider using LED lighting, which is energy efficient and long-lasting. Eighthly, pay attention to the location of electrical equipment. Locate electrical panels and other equipment above the floodplain to prevent water damage. Use watertight enclosures for all electrical equipment to protect it from the elements. Ninthly, proper signage is critical. Clearly label all electrical panels and equipment with appropriate warnings and instructions. Post signs indicating the location of emergency shut-off switches. Tenthly, adhere to all applicable codes and regulations. The NEC provides minimum safety standards for electrical installations. Local codes and regulations may also apply. Consult with a qualified electrical engineer or inspector to ensure compliance with all requirements. When selecting conductors, refer to NEC Table 310.16 for allowable ampacities based on conductor size, insulation type, and ambient temperature. Remember that the ampacity of a conductor must be derated if it is installed in a conduit with other conductors or if the ambient temperature is high. Consider the voltage drop in long conductor runs. Voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. Use larger conductors or increase the voltage to minimize voltage drop. Calculate voltage drop using Ohm's law and the conductor's resistance per unit length. Grounding is a critical safety feature in marina electrical systems. A properly grounded system provides a low impedance path for fault current to return to the source, tripping the overcurrent protective device and energizing the circuit. The grounding electrode system should consist of a ground rod, ground plate, or other approved grounding electrode. Bonding is the process of connecting all metal parts of the electrical system together to create an equipotential plane. This helps to prevent voltage differences between different metal parts, which can cause electric shock. All metal parts, including equipment enclosures, conduit, and piping, must be bonded together. GFCI protection is required for all receptacles located within a certain distance of the water. A GFCI is a device that detects small leakage currents and trips a circuit, preventing an electric shock. GFCI receptacles should be tested regularly to ensure they are functioning properly. Surge protective devices are designed to protect electrical equipment from voltage surges caused by lightning, switching, or other events. SPD should be installed at the main service entrance and at individual branch circuits to provide comprehensive surge protection. Regular inspection and maintenance are essential for ensuring the safety and reliability of Marina electrical systems. Inspection should be performed by a qualified electrician who is familiar with the NEC and local codes. Maintenance should include cleaning and tightening connections, inspecting wiring for damage, and testing GFCI receptacles. In addition to the NEC, other standards may apply to marina electrical systems, such as those published by the American Boat and Yacht Council or ABIC. The ABIC standards provide guidelines for the design and installation of electrical systems on boats. Consider the environmental conditions at the marina when selecting electrical equipment and materials. Marine environments are typically corrosive due to the presence of salt water. Use corrosion-resistant materials such as stainless steel, bronze, or fiberglass to minimize corrosion. Protect electrical equipment from direct exposure to sunlight and rain. Select wiring methods that are suitable for wet locations such as type THWN or THHN wire installed in conduit. Use watertight enclosures for all electrical equipment. When designing the marina's electrical system, consider future expansion. Provide adequate capacity in the service entrance and distribution panels to accommodate future loads. Install spare conduits to allow for future wiring upgrades. Work with the local utility company to determine the available power supply. The utility company will need to provide adequate power to meet the marina's load demand. Coordinate with the utility company on the location of the service entrance and the type of metering equipment required. Create detailed electrical drawings of the marina's electrical system. The drawing should show the location of all electrical equipment, wiring routes, and circuit schedules. The drawings should be kept up to date and readily available for maintenance and troubleshooting. Obtain all necessary permits and approvals before starting any electrical work. Electrical work typically requires permits from the local building department or electrical inspector. Ensure that all work is performed by qualified electricians who are licensed and insured. Document all electrical work that is performed at the marina. Maintain records of all inspections, maintenance, and repairs. These records will be helpful for troubleshooting problems and for demonstrating compliance with codes and regulations. In summary, marina wiring design requires careful attention to detail and a thorough understanding of electrical codes and best practices. By following these guidelines, you can help ensure the safety and reliability of the marina's electrical system.